I want to ask, so you did nearly 500 game simulations of nearly 500 groups of students here and in Texas. And were you there for?
I participated in the experiments here at USU. All of them. So
and you got your students by. Tell me how you got your students.
We recruited through introductory courses here in the college, and that's for IRB purposes. It's really all I can say about that is we recruited through introductory courses here in the college. Students had the option of playing or not. It was totally up to them. They could opt out at any time. Those who did choose to play were paid. It was part of the incentive of the project. So going back to the Common Pool resource thing, what makes a Common Pool resource system or situation interesting is that there's always an incentive for an individual to take as much as they can. But in the short run, that's beneficial to them, but in the long run, that's beneficial or harmful to the group. And so it's what's called the social dilemma. And so if every individual starts acting selfishly, then the whole resource goes away and nobody can use it. And so part of the payment was when you played this computer game, it's a lot like Pac-Man. The more tokens you harvested, the more money you got. So there's always the temptation to just go and harvest as many tokens as you can as fast as you can. But when everybody starts to do that and the tokens are gone, and now you just sit there for however long the round is. We played 6 rounds and there are no tokens. But if you slow your rate of harvest and you work together, then over the long run, everybody makes more money.
Now I understand that you're going to be analyzing all of this and making a model. Any initial thoughts, and they'll be in the white paper, but what did you see?
So we did 2 types of experiments. Okay, so typically when people study these Common Pool resource settings, which is like a model system for social dilemmas in general. Social dilemmas happen in life all the time, where you have this temptation to act selfishly, but it would be in the best interest of the group if you didn't act in your complete self-interest and you gave up a little bit or you shared a little bit more, things like that. So Common Pool resource systems are used as like a model system for this general problem a lot, but they're always treated in a static context. So you're just treated like the system is there and it doesn't change. The underlying properties of the system don't change. So what's kind of novel about our experiments, or what is novel about our experiments, is that we get people to start working in this Common Pool resource system together and figuring it out. And then we change the rules of the game on them. And there are 2 ways that we change the rules of the game. One, we change how quickly the tokens regenerate, which you can think of as simulates a kind of ecological change that might happen in our environment. So like if the real system was a fishery, it might be some change to the ocean current that caused the rate of reproduction of fish to go down.
Did they go in knowing that they were working?
No, absolutely not.
They were told just to play the game.
They just knew how the system worked and how they could make money working in the system. And that was by harvesting the tokens. And of course, we're trying to create some realism here. Of course, in real life, you don't know when the ocean current is going to change or a dry period is going to come and that kind of thing. So that was one set of experiments. We ran all of those last year. We called it the ecological change experiment. And we ran all of those last year at USU and UTSA. So we've analyzed all those data. And so what we find is very interesting. So we collected data on the general and social intelligence or theory of mind of all the individuals in every group. And so what we found is that groups of individuals who had higher general intelligence, which is your ability to think abstractly and sort of in a mathematical way, or what you phrased as nerds. But there's also a verbal component to it. Super good language skills. You can really have high general intelligence can be associated with very good language skill. Those groups that had higher general intelligence, did really well when we created a positive ecological change. So I in my examples to you, I was emphasizing the negative. The ocean stream changes, the reproductive rate of fish go down, or there's a dry break. Could also have a positive change, right? Right? And so what we found is when there was a positive change, the groups with higher general intelligence recognized that change and took advantage of the novel opportunity much, much better than groups that had lower general intelligence. Now, when there was a negative change, general intelligence was a much, much weaker predictor of how groups did, but the primary predictor of how groups did was social intelligence, or this theory of mind. So when there was a negative change in the resource base, groups with higher social intelligence did much, much better than groups with lower social intelligence at recognizing the change and renegotiating how they were going to share this resource space and how quickly they were going to harvest. They were much better at that than groups with lower social intelligence. So the story is, when things get better, general intelligence is really good because it helps you recognize novel opportunities. When things get bad, the social intelligence is much more important because now when it gets bad, you start to have these interpersonal sort of conflicts that start to become more stark, and the higher social intelligence helps you deal with those and manage those.
Did the students recognize that, like, for not being maybe subconsciously, such as, let's find a way to work together versus those who, did they work it out among themselves who had more or less, or who was more useful at the time?
I think the students all recognized once this, because we trained them how to play the game and how the resources worked. And they all recognized, many of them recognized from the beginning, we need to work together to make this happen. And of course, a lot of people in real life recognize that as well, right? But then things happen, and that's when this negative change in how quickly we had tokens regenerating really affected those groups. And so there were a lot of groups that had been working together, and then the negative change happens, and that cooperation breaks down. And it tended to be groups with lower social intelligence would be where that cooperation would break down.
So you had groups comprised of the different kinds, like maybe 2 more social intelligent people here as opposed to 6.
Well, all groups were groups of 4.
Right.
And we did no a priori sorting of individuals. So it was just random how they came together. But we had data on each individual so that we could then go in and look at the performance of groups related to not only their social and general intelligence, but we also calculated religious diversity of the groups. We calculated the diversity of majors in each group. We looked at gender composition of each group, a bunch of other factors that we were trying to control for. Say, okay, are these effects of these intelligence capacities that we're seeing just correlated with these other social variables that we often think about are associated with better cooperation.
So you had engineering students as well as English students?
Yeah, we had from across the campus, we had engineering, English, sociology, anthropology, bio, physics. Every major was, there were lots of nursing students. Almost every major was represented. And so part of the reason this is a multi-site experiment, meaning we did it in Texas and here, is because they're very different background populations. So UTSA, almost 65% of the students are Hispanic.
Right.
That's very different than here. Here you've got a dominant religion of the student body. There you do not. And so, and because UTSA is situated in northern San Antonio, which is military town USA, you have actually got students. You have students from Saudi Arabia participating in these experiments there. You have much more diversity in that way. But what we found is that these results were consistent both at USU and UTSA, despite these underlying differences in the populations. So
you can remove culture?
We can't remove it, but we can try to control for it statistically. And the way we tried to measure that was, ethnic diversity, religious background, those variables that I was mentioning. So we knew all of that from each group and each individual.
Any other pre-conclusions, like gender-based, for instance?
Yeah, so we did replicate the result that, which has been found a number of times, that groups with more females tend to cooperate more and be more cooperative. So you do see that in our data as well. It tends to have a weaker effect than the intelligence, especially the social intelligence.
Right.
It tends to have a weaker effect, but we did replicate that, and we also replicated, I can't remember right off the top of my head, but it's in the paper. I think we also replicated the negative effect of religious diversity on cooperation. So more diverse religious affiliations in a group tended to have a weakly negative effect.
Really? So if they
that's
were
been
more of
found.
one group, they did better?
Yeah, if all the students had a common religious background, but that finding is weaker. I would say it's not as consistent across the analysis that we did. Most consistent finding would be the general intelligence, social intelligence, and then also percent of group made up of female. Those are the three most things that from our study we can say were really affecting things. And the percent female is very consistent with other work that's been done in static environments.
So you, Professor Cole, wrote the paper?
No, myself and Dr. Baggio, who's over in Natural Resources.
Okay.
Tom Coyle also wrote the paper, and all of the students who participated in the project participated in writing the paper as well. So, and a couple other professors here at UTSA who sort of had minor contributory roles in the design and actually implementing the experiments. Also contributed, read through the paper, gave comments, that kind of thing. So we've got about 8 or 9 authors, I think, something like that.
So what's next?
Well, what's next is we're going to move on to the next experimental data set, which is what we call the group size experiment, in which instead of changing the way tokens grow, we change how many people are in the group. So you get used to working with 3 other people, and now all of a sudden you've got a group of 8 instead of a group of 4 that you have to deal with in this environment.
Same subjects, same different group?
Different, same student populations.
Okay.
But not people who participated in one experiment are not participating in the other. So we got to keep that separate. You want people who have some ignorance of what they should be doing, because humans are very smart. So, and once you've done this once, you start to figure out what's going on, and you get much better at it.
8 really seems to raise the stakes of playing a single game.
Yeah.
Or managing a single resource.
Yeah. So it's meant to simulate a sudden immigration event, which we see a lot in society. And so if you're already in a situation in which cooperation is really important for keeping that resource together, how's that going to perturb the system, and what underlying attributes of groups are better at dealing with that change? So our hypothesis is, again, that you increase the group of 8, that social intelligence is going to be really important.
More important. Who do you see utilizing in the research? We talked about companies, workplace dynamics, military uses.
Yeah, I mean, anybody who's interested in teams that have to navigate changing environments, especially when individual and group level interests conflict, which can in all kinds of settings. Right? You want to get that individual promotion, which means you got to try and do things and make yourself look good sometimes. But also the team needs to get things done, and so sometimes you can have that. So any time you have that kind of situation, I think it's relevant. We also see it as relevant to sort of policy discussions, at least, about how to develop sustainable resource use and try and move towards a type of management of natural resources called adaptive management. Adaptive management is management where you're letting the resource vary more, and you're constantly assessing what's going on and trying to change your rules of the game as you go, as opposed to command and control management, which is you keep the resource in a very narrow range of output variables. We want to harvest X number of fish every year, and we don't let it vary. So that's command and control management. So it could be useful for that and trying to figure out how groups work to make decisions in the more adaptive management strategy, which is more bottom up rather than a command and control, which is some policy regulator tells you how many fish you can harvest
Basically a general
each year.
intelligence guy.
Yeah.
I'm just kidding.
Yeah, I mean, you can think of it that in that system, general intelligence is highly valued.
Right.
We're going to analyze the system. We're going to look at, fish capture rates and what's the maximum sustainable yield. We're going to set a value, and we're going to manage boat sizes and net sizes to keep the value at that level. Which the other way is very different. You still need an understanding of the system, but you also need to let it vary. And if you let it vary, not get upset when it varies in the wrong way. Right?
Well, and everything seems to vary.
Yeah.
So that would be a natural situation.
Yeah.
So how long do you anticipate the work going on this?
We're right on schedule. It's a 3-year project.
Okay.
So we've done all of our data collection in the first year. We're even a little ahead of schedule in having it analyzed some of the data and put a paper together. I think we're all pretty happy with the paper. And so we'll still move on. And so the next step for us is to begin analyzing the rest of the data, but then also start building toward follow-up studies.
So you'll have one more set of tests.
Nope, all tests are done.
I meant sets as in groups of 4, groups of 8. One more round, perhaps.
For the follow-up studies?
Yes.
We could. That could be one thing we do. We don't know. We've kind of got to decide. Let's sit down and we're going to have a workshop in December, January. We're going to sit down and look at all of our results and sort of decide, do we want to have follow-up tests? Do we want to design a slightly different experiment? Do we want to take this experiment to a different population? For instance, put it out there and have people who are, in different areas play the game and participate in the experiment, and not instead of just students. We're not really sure at this point, but we're kind of working through those possibilities.
Okay. What classes do you teach? What do you, you're an anthropologist, but what kind of anthropologist would you call yourself?
Well, by training, I'm an archaeologist, but I have a very diverse research program. I mean, this project's only one part of what I do. So the classes I'm teaching right now, I teach quantitative methods. It's a graduate class. I teach ancient civilization course, which is all about the development of political complexity and trying to understand what are the drivers of the development of political complexity and then the collapse or reorganization of ancient societies.
Interesting.
And then I also teach anthropological theory, which is a course that all anthropology majors have to take. It's a foundational course they have to graduate. So that's taught. I teach that every spring. I teach a graduate course in social ecological models, so modeling human resource interactions.
Which this fits very nicely in.
Yeah. What else do I teach? What's it about? Oh, I teach Southwest archaeology, and I think it's called Cultures Past and Present of the Southwest, which is where my primary training originally was in Southwest U.S. anthropology.
Do you see your career arc maybe swinging back to that more, taking more of your time?
Yeah, I don't know. I keep an interest in the Southwest, and I mean, Utah's part of the Southwest, and so we've got a big project that we've started called People 3000, where we're looking at changes in climate and human population and energy consumption over the last 3,000 years. One of our main case studies is Eastern Utah and southeastern Utah, and so yeah, that's part of what I do as a moving forward. It will be.
Who are you working with on this project?
That project, it has a number of international collaborators. So here at USU, there's Dave Byers, who's here, who's an archaeologist, and Judson Finley. Justin DeRose, who is a paleoecologist over in natural resources. And Molly Cannon, who's over in the museum. She's in charge of our education and outreach, part of our project. So those are the folks collaborating here, and then we collaborating with several colleagues in Argentina and several colleagues in Santiago, Chile. Those are both case studies that are part of the larger group. We have a colleague at Pennsylvania State who's collaborating.
And you're all contributing to a database that you can look at?
I can give you the website. It's called People 3000. If you Google it,
it sounds really interesting.
we had to. It was a competitive grant process. We had to apply for this working group, and so then they set up a bunch of infrastructure for us. Really, the idea is to create this global network of people who are interested. And so what we're doing is bringing data together from these different case studies, and we're going to use some models to sort of try and integrate these different case studies and come up with a way of analyzing them in an apples-to-apples way.
It sounds like a good project.
Yeah, it's interesting. What we see this really redundant pattern everywhere we look. Most places we look, small-scale societies. Over the last 3,000 years, you get this, between 2,000 years ago and 800 years ago, you get this real ramp up in the way people, how intensively people are using their environment. And then it just falls off about 750 years ago. And that's kind of coincident with the transition of the climate to the Little Ice Age. It's not the Little Ice Age, but it's this transition period. And what's interesting about this transition period from the medieval, what's called the medieval warm period, when it's really warm, to the Little Ice Age, when it gets really cold, is that the climate goes haywire. It doesn't really have a set pattern. It starts, all the signals that we can have to sort of track changes in temperature and rainfall, they become highly variable. Kind of process happening in which you're getting this rapid economic development, political development, rapid increases in energy consumption. And what that does is it begins to decouple the human system from the climate system. And it sort of gives you this false sense of security and gives you this sense that, you're in a stable kind of economic system. And so what we're trying to figure out is what are the vulnerabilities of that. These archaeological case studies are telling us perhaps that there are benefits of that. I mean, this university is an outcome of that economic development trajectory, right? So there are lots of benefits to that, but there are also vulnerabilities that we need to think about potentially moving forward.
So it sounds kind of like a climate version of the Black Death in the Middle Ages.
Yeah, I mean, if we're adapted to a certain type of climate and sort of expecting it to be within a certain range. Once it moves out of that range, it's going to create stressors for us, big time, yeah.
Very timely.
Yeah.
Very good. Thank you, Jacob. Okay. Appreciate your help.